Hi guys! Today let's take this rough 3D render that's clearly not production ready and transform it with AI into a clean, high-end image without losing control over the architecture. In this example, we also saved a ton of modeling time by using AI to generate mullions and other details based on specific prompts. But this workflow works just as well when the architecture is fully rendered and AI is used only for the surroundings. Here AI didn't do a great job with the panels behind the glass, so we simply took these elements from the original 3D render. This approach also resulted in accurate, realistic glass reflections. Think of it like traditional matte painting, but instead of doing everything manually in Photoshop, we let AI handle the heavy lifting. The details are high resolution and great quality, more than good enough for final delivery. With the same approach, you can easily create additional views or even create animation in minutes afterwards and upsell it to your client. This video is sponsored by us. This workflow is part of our AI in ArchViz course. When you join, you have access to many step-by-step lessons that are already published, ready-to-use ComfyUI workflows, monthly Q&A sessions, and new content every week. Now is a great time to join. Last week was my birthday, and we launched a quick sale, 20% off all courses and bundles, only till the end of this month. Let's jump into the process. The first step is to set up cameras and render previews. It's important to explain what kind of images you should render before moving into AI. Here, we have basically a clay render with a really simple grass in the foreground and some trees scattered around. You don't need more than that. If you are really short on time, you can even work with images as simple as this one. But the render with grass gives a better output. For the next step, let's move to ComfyUI. We will be generating images based on the rendered previews and the references. In this case, we have this reference that we generated while exploring this project. We'll generate moods using Flux Klein, along with a LoRa made by Ismail, which you can download from his website, Form Finder. Alright, we can start generating. This is an example of the artifacts I am getting with Dipon, and high resolution. I wanted to show you in case you are getting them too and don't know why. The limit for a stable image seems to be 2 megapixels. Let me show you a result with 1.5 megapixels and the same prompt as before. The artifacts are gone. Let's look at the effect of the LoRa. With the LoRa turned on, the vegetation looks significantly better, and the reading of the reference image more accurate. The greenery feels richer and more integrated. At this stage, I don't care about the architecture, which will be handled later. This model, Flux Klein, is extremely sensitive to prompting. You can see that the starting image for these tests is very simple and contains no greenery. That was intentional. I wanted the model to have maximum freedom to read the reference image carefully and creatively transfer vegetation, atmosphere, and environmental elements instead of being constrained by trees or landscaping that were already present in the base image. Now, let's see what happens when you use our white render as the base. The seed is still fixed, and I'm keeping the same prompt that generated the previous image without changing anything. And look at this result. It looks amazing. It added a path in the middle of the greenery, but I don't mind that. If needed, I could easily fix it with a bit of inpainting. Great, let's move to the next step. We have to go back to 3D and match the lighting of the mood you've picked. The goal is to match both the light intensity and the light direction. This is important because you want to keep the building from your 3D scene, not from the AI result. The architecture needs to remain fully under your control and completely accurate. AI is great for mood, context, and atmosphere, but the building geometry must stay precise. We need to match the overall brightness level, the direction of the sun, the general mood, and contrast. I like to lock the light direction and intensity first. Once that is set, I move on to fine-tuning the image using the post-production tools in the frame buffer. Things like LUTs, tone mapping, exposure adjustments, and contrast controls. Alright, this is now fairly close. At this point, you can render a high-res image. While we were waiting, we had to upscale the generated images to the high-resolution final quality. We've used the ComfyUI upscaler workflow developed by Maurizio for our AI course. As you can see, the results are great. Now we have everything. We can combine everything in Photoshop. At the bottom, we have our original render, and above that, there is the upscaled AI image. In the meantime, we decided to regenerate it again with the same process without the path. The details look great. It looks like a photo. That's the beauty of this approach. It's like traditional matte painting, but instead of searching for photos, we use AI. Obviously, the building doesn't look good, so we need to mask it and use the original render. That's not a problem, because we rendered masks we can use to select the architecture. After that, we simply color-corrected the AI image as well as the building. Nothing crazy complicated here. Next, the building generation. This step is optional. If you have a fully modeled architecture, you can render it and use it here. We didn't have all the details, so we've used AI to create it. Let me show you quickly how it was done. First, select the building with some common aspect ratio AI is trained on. Let's say 4:3. Then, let's duplicate it and make a smart object out of this layer. Then I send that crop to the AI workflow to enhance the architectural detailing, adding mullions, metal profiles, and structural refinement to the glass dome. As always, I used ChatGPT to help me craft the prompt to generate the building details. I have to say that in this case, I wasn't fully satisfied with the result I got from Klein. Since we are simulating a real project and aiming for a client-proof level of quality, I reused the same prompt in Nano Banana and then upscaled that result to reach a higher standard. Let me show you the different results. First, the version generated with Klein, then the result from Nano Banana. Let's go back to Photoshop. I placed the generated image above. The problem was that the panels behind the windows were not good enough. The fix is easy. I just masked out the glass areas and used glass from the original render. This also gave us the original reflections. The next step is adding people, and I'll quickly show you the procedure again. It's very similar to the one I used for enhancing the dome. The starting point is this image with the gray silhouettes. I created a cropped region using the same ratio trick I mentioned earlier, so the image matches common training proportions. Then I refined the selection a bit to isolate only the gray silhouettes. After that, I moved back into Flux Klein to generate the people. Once again, the final version I used in the composition was often generated with Nano Banana Pro rather than Klein. However, in this specific case, Klein delivered a pretty solid result, so you can absolutely use it for this kind of task. It doesn't reach the same level of refinement as Nano Banana Pro, but that's part of the trade-off. If you're aiming for the highest possible quality, Nano Banana Pro is the better choice. If instead you want fast free iterations running locally on your machine, then Klein is a very solid option, at least for now. For some of the people, I used the People Refiner workflow that was included at the course launch. We are now wrapping up this image, and as you can see, there are some visible mistakes and seams. These mainly come from a typical issue in Flux Klein: slight shifts and scale changes caused by the scale to total pixel node. To fix this, we created several smaller regions and used Flux Klein to inpaint only the areas where parts of the image were missing or misaligned. Instead of trying to correct everything at once, we worked locally and precisely. Of course, you can do the same directly in Photoshop or with any other AI tool you prefer. In our case, we moved around the image, generated multiple small inpainted regions, and turned each of them into smart objects. These were then blended back into the main composition to refine and improve the final result. The last group is the one I call Overall. It doesn't contain any AI work. This is where I applied the final finishing touches. Let's break it down one more time. We started with a simple 3D render, then generated this mood, masked out the building, color-corrected the surroundings, as well as the architecture, generated the building with more details, masked out the glass, added people, fixed the edges, and finally color-corrected the whole image again. Hope you enjoyed this. If you want to go deeper and learn AI with us, join our course. There are already plenty of lessons available, and new ones are added every week, so you'll always stay up to date. And here are a few more videos you might want to watch. Bye-bye!